Okay, greetings once again, guys, and welcome to another edition by iCampSA. This edition, we're looking at linear regression, still on statistics, and our focus is the 2020 and 2017 exam, that is the November and the June exam respectively. This is grade 12 mathematics, so let's go and have a look at the questions. So from the 2020 November exam, we're given this question here, where we are told a mathematics teacher was curious to establish if a class mathematics marks influence their physical sciences marks. In the table below, the mathematics marks of 15 learners in her class are given as percentages. And then they give us the scatter plot for these marks here. Then the first question says, determine the equation of the least squares regression line of the data. So we've done a lot of these already, but let's go and have a look at what is happening. So 1.1. So the equation of the least squares regression line is always given by y equals a plus bx. Okay. So essentially we need to figure out what is the value of a and what is the value of b, because the others we know. Okay. We know that for x, this indicates the marks for mathematics. And what you need to remember is that for y, this indicates the marks for physical sciences. So let's go ahead and find our values of a and b. And what you should note is that for you to find your a and b, you should use your calculator. Our calculator does the work for us to give us our equation or a regression equation. So let's go ahead and see how do we deal with that. So if you would observe, this is my apologies. Let's try again. Let's go and get our calculator and let's put up our note. Right. So there we go. This is my table. So let's clear it, shift empty. So this is our table, and in your calculator you'll go shift, then you'll go 1, then it will allow you to go to stats and you'll be able to see where you can populate x and y. So I'm going to start with maths, which is 26, 62, if you look carefully, 21, 33, 53, 76, then 32, then 59, and 43, 33, 49, 51, 19, 34, and 85. Then we can go and put the corresponding y value, which is the physical sciences marks, that is 34, and then 67, 28, 65, 76, 26, 73, 50, 39, 57, 51, 24, then 41, and 80. Okay, that is what we now have. So what I'm going to do is to go and check for the values of a and b. So when you now have your table, you should just say shift 1, and then in your calculator you'll be able to see stats, and then you'll say reg, which is for regression. Then you can go and click there, and you will see that we end up getting our value for a. So what is very important is also for you guys to double check your table. So when I look at my table, I have a 34, and then 67, 28. If you look carefully, I was supposed to have after 28, 46. So we should put 46. Enter. Then if you look carefully, then I'm supposed to have a 65 after 46. And I'm supposed to have a 76. And then I'm supposed to have a 26. Then 73. And then 50. And then 39, which we seem to have. then 57, which is correct, then 51, which is still correct, and 24, and then 41, which is correct, and 80, which is correct. Okay, so it's very important that you just double check. Okay, shift 1, we can go to our regression, the value of A. What we end up finding for our A is 9.5. So for A, we're finding 9.500. If we round it off to 3 decimal places. Then shift 1, regression, we go to B. Then you will see that the value of B, what we are finding is 0. I'll make it 3 decimal places. So this will be 909. Okay, so that is what we have. So we're now in a position where we can write the expression they're looking for. So therefore, our y will simply be A, which is 9.500 plus 0.909 times x. Okay, so that is our equation of the least regression line for this data. And then for 1.2, what we are required to do is to draw the line. Okay, so others would call it the line of best fit. So really it's just the same thing. So there's a couple of things that are important that we need to note. That is y equals, so you have 9.500 plus 0.909 times x. So the first thing that you need to note, which is very important on our sketch, is this here. So this here becomes our y-intercept. Okay, so meaning if we draw a line, we must have that as our y-intercept. Okay, and then what you need to do afterwards is you need to choose a couple of points. So you can choose, for example, 4 points. So what is our equation at, let's say, 10, 20, or at 30, 40, 50? So what we should do afterwards is choose, let's say, 5 points that we are going to use to do the plot. So I'm going to choose the points to be at x equals. So I'm going to take a couple of them that are very easy to plot. So we'll start at 0 and then take one at 40, then take one at 50, and then take one at 60 as an example. Okay, so these become our 5 points. So let's move this to here. So these become our 5 points. So if we go now and draw our straight line, you'll see that we should be at 0.9 something. So what we are going to say is that according to this thing, we are going to have a, let's say, 0.9500 somewhere there. So in order to make our life to be easy, in fact, let's go and plot this on the next page. Okay, so you'll see that we'll have a point somewhere there that is going to be 9.500. Okay, and then what we need to do is to ensure that our slope becomes exactly what it is. So that is 0.909. So we can go and figure out what is the x value at 0. At 0, the x value is 9.5. And then we can go and figure out what is the x value, say, at 40. And the y value at 40, and you'll find out at 40, the y value which we get is 46. And then at 50, when you punch in, you'll see that the corresponding y value will be 55. Okay, and then we can go to 60, you'll see that the corresponding y value will be 64. So all what you need to do is to just try and match some of these, and then you just draw a straight line between them. So let me see if I can match some of them. So let's take 40. So for 40, we said we have 40 and 46. So if you look carefully, we have 40 and 50 here, and it's going in steps of 2. So 42, 44, 46, 48, So 46 is here. Okay, so that is going to be one of our points. So just gonna put in a blue mark there. So that is at 40. And remember, what we are using to get this is just the equation. Okay, that's very important. No, I don't want to delete this. I want the lines rather. Okay, why is this doing this? So let's have a look at the next one where we had 50. And if you look at 50 on the previous page, it matches with 55. So 55 would be right about there, right? And then we can just make sure that we put in our point to be somewhere there, okay? And then we can now delete these lines, right? And now we are in a position where we can just draw a straight line connecting these. We can go and do the other 2 points, but yeah, this should be okay for us to be able to draw a straight line. So my straight line will move like this past these points here. So let's tilt it. Let's see. So that becomes our straight line, guys. So we can just re-choose it to be there. But yeah, it passes through some of these points. So that is what they would be expecting us to be able to do for this problem. Okay, I hope that this does make sense. And then now for 1.4, so for 1.2, what you should do is you should see the next page, okay, in order for you to see the answer. Now let's go to 1.3. So they say predict the physical science mark for a learner who achieves 69 for mathematics. So if you look at 1.3, we are told that x is equal to 69%. That is maths. And now we are trying to figure out what is y, which is their physical science mark. So all what we need to do is we just need to do the plugging here. So we are going to have y equals, if you look at our equation, it's 9.5 plus 0.09, sorry, plus 0.909 into 69. Is it a 69? Yeah. And then I'm going to go to my calculator and quickly punch this. So what we have is 9.5 plus 0.909 times 69. And what we end up getting is 72.2%. So a learner who's getting 69% in mathematics, according to this regression line, they are more likely to get 72% in physical sciences. Okay, so that becomes then our answer. So what is our answer? Our answer is that the learner is likely to get 72%. Okay, so I hope that this does make sense, guys. Now let's have a look at the next question. They say write down the correlation coefficient between mathematics and physical sciences for this data. So 1.4. So what they want is what we call the correlation coefficient. Correlation coefficient. So the correlation coefficient is represented by R. So the question is simply, what is R? So we go back to our calculator. We're no longer looking for B shift 1. You would go to stats, then reg, which is for regression. As you can see here, I can read off the value. So it's 0.95, okay? Because it's times 10 to the negative 3. So in your calculator, you would see 0.95. So therefore, the value of R is 0.95, okay? Done with that. Then they say calculate on the strength of the correlation of mathematics and physical sciences for the data. So we're looking at 1.5. So we are calculating on the correlation between these two. So if we look carefully, we have an R value of 0.95. And we know that 0.95, that is because it's close to 1, that's a strong, but it's positive, so it's a strong positive correlation. So that is what the R tells us. So back to the context of the problem, what we can give as the answer is the following. We can say that there's a strong positive correlation between the marks for mathematics and physical sciences. So let's note that. So we are saying there is a strong positive. Okay, because remember, we can have a strong negative correlation between data points. So we have a strong positive correlation between maths and physical sciences as physics and physics marks. Okay, it is that simple, guys. We are done. There's a strong positive correlation. So meaning what we get when we predict using the formula is an answer that is quite accurate, if we can use that term. So let's have a look at 1.6. What trend did the teacher observe of the two results? Now we need to make an observation. So look at what happens. So as mathematics marks increase, you will see that the physics marks, they also increase. Okay, so meaning a person who's scoring higher in mathematics is more likely to score even higher in physical sciences. And even our gradient, the value of B, because this is positive here, then that is what we can conclude. So we can go ahead and say 1.6. So what we can say is that learners score higher in physical sciences than in mathematics. Okay, in maths. So what this means is if a learner is passing mathematics well, they are gonna get higher marks in physical sciences. That is what this means. So we can further say if a learner is getting, let's say, mark X for maths, they will get a mark greater than X for physics. So greater than X for physics. So this is very important for us to make sure that we do understand, guys. Very straightforward. We can see from the trend, the slope is going up. So they are more likely to get, higher marks. So in fact, we should use they will more likely get greater than X for physics, okay? Because there's exceptions, as you can see. For example, if you look at this learner here, for maths, they got just above 30, but for physics, they just got below 30, you see? So this is an example of an exception. So maybe let's note it. So if you look at this learner here, who got just above 30, but got just below 30 for physics, such learners do exist and they are exceptions. So you see this one here is a higher math mark. Okay, and it does happen, you know, that there are exceptions like this one. But if you look at in the majority, you know, the guys, they are getting marks for maths which are higher than those which they are getting for physics. Sorry, for physics, they are getting higher marks than they are getting for mathematics. Okay, so that is that, guys. Let's go and have a look at the next question. And the next question comes from the 2017 June exam, and we are told an IT company writes programs for apps. The time taken in hours to write the program and the cost in thousands of rands are shown below. So we need to determine the equation of the least squares regression line. So 1.1, very simple question. They want us to figure out what is the equation y equals a plus bx. Okay, essentially we need to try and figure out what is a and what is b. So for that we need our calculator, and we need to use our table. So clear this, shift 1, we go to data, then there's my table. I just need to clear it. Then we can now go ahead and populate our table. So if you look carefully for the x's, we have 5, then 7, then 5, then 8, then 10, then 13, and then 15, then 20, and then 18, then 25, then 23. Then we can go ahead and put in the cost in thousands. So that is 10, that is 10, that is 15, 12, 20, 25, 28, 32, 28, 40, and 30. So let's quickly double check. So I have 5, 7, 5, 8, 10, 13, 15, 20, 18, 25, 23. Okay, let's look at the y's. So we have 10, 10, 15, and then 12, then 20, then 25, then 28, 32, 28, 40, and 30. Okay, that looks about okay. So we can now go ahead and start reading our data. So shift 1, stats, regression, then we can get the value for A. So if you observe carefully, the value of A we are finding is 4.8. So it's 4.806. Okay. And then you will see that for B, let's go shift 1, stats, regression, then we go to B, and that is 1.323. Okay. That is what we are getting for this. So we can now write our equation finally to be y equals, if you look carefully, we have 4.806, then plus 1.323, then this is x. Okay, so that is what we have. And then let's go to 1.2. So what we have here, that is our answer. So let's go to 1.2. Use the equation of the least squares regression line to predict the cost in rands of an app that will take 16 hours. So essentially what we are told here is that we have x equals 16 and we want to figure out what is y. So I'm going to use the equation y equals 4.806 plus 1.323 into 16. So let's quickly punch in my calculator. 4.806 plus 1.323 times 16. What we end up getting is 25.97. Okay, so what this means is we'll have 25.97 thousand rands. Okay, so this means our answer is we have 25,000.97 97,000. So 1,000 rands. Yeah. So that is what we are going to pay for an application that is going to take 16 hours to develop. Okay. So this is according to this equation of hours. So what we can do is we can write our answer, slightly differently, because instead of saying 1,000, we can just write it as 25 and then 970. Okay, that is 25,970. Okay, so we're done with this. Now let's go for 1.3. So in 1.3, we are required to find the correlation coefficient. So they want the correlation coefficient. And by correlation coefficient, we are referring to R. So essentially, what is R equal to? And as we do with all problems, what we are going to do is you're going to use your calculator to get this. It's very simple. So let's go to the calculator and we say shift 1. In your case, you would see stats, then you choose reg, which is for regression. Then you will see the value for R. So R is 0.949, which if you round off to 2 decimal places, it will be 0.95. Okay. So our R value will be 0.95. Then let's go to, so this here becomes our answer, okay? That's our correlation coefficient. Then let's go to 1.4. So 1.4, they are saying for each app that the company writes, there is a cost that is independent of the number of hours spent writing the app. So meaning there's a standard fee that the company charges, which is irregardless of the number of hours that it costs to write the app. Now let's think about our regression equation. Okay, so if you look at our regression equation, what we found was that it is 4.806 and then plus 1.323 times x. So we are asked, what is this fee that the company charges regardless of the number of hours spent? So let's think what happens at x equals 0. What this means is no hours worked. Okay, no hours worked. But if you look carefully, when you sub x is 0, you get y, which is 4.806. So although there's no hours worked, there is a fee that seems to be getting charged at x equals 0. And this would be the standard fee that the company charges. Okay, so what this means is that it means our answer. What this means is it means the company charges a standard fee of about 4,806 rands before it can even get the work done. Right? So we can make a note, which is that the company charges a base fee, or just a fee. So a base fee of, if you observe carefully, that would be 4,806 rand for any project. Not for any, but for all, rather. For all projects. Okay, so this means regardless if a project is going to take 1 hour, the company will definitely charge you more than 4,806, because this here becomes their y-intercept. So meaning with no work done, This is the fee that the company charges in thousands, right? So I hope that you guys are able to make sense of the concepts that we do cover in this lesson. Please do make sure that you do a lot of practice and you understand what we did here. So for this very short lesson, this is our last problem. And as always, this awesome lesson is brought to you by iCampSA. So please spread the love, spread passing, share with friends. Cheers, guys.